Okay, when we last left off, we had a player, we had a background, we had a level, we had physics and collisions enabled, and we even had two buttons on the screen. But the buttons only respond when you let go of them, and we need them to respond when you touch them and when you release them. So let's go ahead and start making some modifications. First thing we're going to do is open up Finder, and we're going to go into our behaviors folder for our project, and we're going to make a copy of the generic button behavior. After we make the copy, we're going to rename it to platform button behavior, or just platform button. Once we have a copy of the file, we can go into Xcode, find our new platform button, and start editing. First thing we're going to do is we're going to take care of the internal name of the button behavior. Currently it's generic button behavior. We want to change every instance of that in this file. What I like to do is I like to highlight the variable, hold down Command C to copy it, then Command F to find, and then Command V to paste. So it's going to show me everywhere the generic button behavior is, and I can determine whether or not I need to replace them all. Let's see, generic button behavior is on all the functions and the name of the template, so it looks like I need to replace all of them. So I'm going to go up to the replace command, and I'm going to replace generic button behavior with platform button behavior, and I'm going to replace them all at once. Now we have 0 matches for generic button behavior, and platform button behavior has taken its place. Let's go ahead and close the Find window and move on to the next item. The next thing is the template's friendly name. This gets displayed in iTorque Game Builder, so let's go ahead and rename this one too. Platform button. The behavior type of GUI is how this behavior will be organized in Game Builder's behavior selection list. And the description basically tells you what the behavior is going to do. Okay, right now it says it executes a method when clicked, and the method is called the behavior's owner. Okay, so now it's going to execute methods on touch up and on touch down. The methods will be called on the owner's behavior. Fantastic. Okay, next we have another behavior field for the click image. We don't need to change that. And another behavior field for the click frame, which we don't need to change either. The last behavior field is method, and the description is the method to call on touch up. Since this is going to be a touch up method, let's go ahead and call it method up. Now, we need to also make sure that since we're changing this variable, we change it everywhere we need to. So let's do that same trick again. Highlight method, we Command F to find, then paste method back in. We can see that there are some words method that are inside of text. We don't want to mess with those. And this one's actually a command. We don't want to mess with that either. Here's our variable, method up. And there's another variable method we're going to change to method up. Fantastic. Now we need to add another behavior field to our template. So let's start off by accessing the template object. Add another behavior field. We'll call this method down. And this will be the method to call on touch down. And this will be for a down click. And we can change the description for that one to be an up click. Okay. So now that we have a place to store what method we're going to call, we actually need to call the method. Since it's going to be called in the onClick only when the mouse or button is clicked down, we can find the onTouchesDown method for the behavior. And we can add a check-in to see if the owner, which is the actual button image, has a method call method down. If it does have that method, we're going to have the owner call that method. Let's go ahead and save and test this out. But wait, we haven't associated that new behavior with anything yet. It doesn't even exist in our project. Let's go ahead and reload our project. And look at the buttons individually again. You still have the generic button behavior on it. So let's go ahead and remove the generic button behavior. And now we see when we click on the behavior dropdown that we have a platform button now. Let's click on the platform button, click on add for the behavior, and then we can add our click image, our method up, which will be player left stop, and then we can add our method when we click down, which will simply be player left. Let's go ahead and do the same thing for the right button. We'll remove its existing behavior. We'll add the platform button behavior. Choose its image. Change its method up to be player right stop. And its method down will be player right. Player left stop, player left, player right stop, player right. Let's give this a go. Now when we click on the right button, the player moves right, but when we release the button, player stops. The animation is still happening, but the movement is right. I'd call that a success. A couple of funny things are happening here though, huh? Looks like my screen is a lot bigger than it used to be. And I still have those funny little tiles left over. Let's take a look and make sure that I don't accidentally have two different tile maps on top of each other. Let me go ahead and zoom all the way out so I can click on something that's, so I don't click on anything so I can get to the project properties itself. Well, the first thing I notice when I get into the edit is that my width and height have changed. Now this happens intermittently for me. I'm not sure if it's something that I'm doing or if it's a new feature or has something to do with universal app support. It's easy enough to change back for the time being. Under the Edit tab for the project, we also see that we have a roll-up called Layer Management. This lets you turn on and off individual layers, make them visible or invisible, lock them, and so forth. That's not what I'm really looking for, though. What I'm looking for is in Project, the object tree. This shows me all the different objects that are on the scene. It starts off the scene graph, and we have a tile map. Huh, what's the tile map doing up there? That must be a base object. If I open up the universal set, where all my images should be, I see I have a static sprite, that looks like a background, a tile layer, and another tile layer. Huh, how'd that happen? Well, let's move that one off to the side. That looks like it's the that looks like our original tile layer, and then we have a copy back there. Well, let's go ahead and erase one of them, and then reposition the tile layer where it's supposed to go. That looks a little bit better. Let's give it another run. Cool, we're back to our normal viewport. We don't have that extra bit of a tile in the corner anymore blocking our path, so I think we're cool. Okay, now that we have a nifty new button that has an upstate and a downstate, we can use that same button behavior rather, to create a jump button for us. Let's go ahead and go back to the Create tab and drag out one more circle and position it above the other two. Now let's edit that circle, and if we want it to be a button, we have to make sure we go into scripting and make sure it's part of the button class. Then we have to actually attach the behavior, which is going to be a platform button. It's going to use the same image map. And for the method up, we're not going to use anything for up. We're only concerned about when you first touch the button, you're going to jump. Okay, so for the method down, we're going to call player jump. Now when we save and play the level, oh, our left and right mouse, or right buttons are working. For the moment of truth. There we go. When we click that button, it fires off the player jump method, which adds a linear velocity y, which apparently is a lot greater than the force of gravity or the downward force on him, because he went right off the screen. And also notice that our screen went right back into that same 1024 by 768 resolution. And we'll also notice that we can only hit the jump button once. Alright, let's go ahead and take a look at the code and see why you can only jump once. Alright, here's the player jump function, and it first checks to see if the player is already airborne. If he's not already airborne, that's what a little bang symbol or exclamation point means. Not. So if he's not airborne, then we get into this function. We set our linear velocity y to -150. That makes him go up. He went up way too fast, so let's cut that number down in half to -75. And then we set the player airborne variable to true. Now this is great. This made me jump. This set a variable to true. But the next time we try to get into the function, he is airborne. No other code stops him from being airborne. So we need to figure out a way to detect when he's stopped, so he's no longer airborne, and we can jump again. While we're at it, we should probably add in the code that will make the player face left and right, not only just move left and right. And having said that, we need to have the correct animation from when we're jumping or moving up rather than moving down or falling. So let's go ahead and get into it. Yeah, we're going to need a function to set the current animation. So we're going to be writing this set current animation. So let's get into the function. And it's a good habit to get into to put a lot of remarks in your code. You know, document the hell out of it. So I haven't been doing that up to this point. I'm going to start doing it now, and I'll probably do the rest of it off camera because it's probably really boring to watch. Okay, so this function determines the state of the player and applies the appropriate flip and animation. And it may wind up doing a little more than that. Let's see. So the function, again, is going to be set current animation, but it's only going to be for the player class. And we're going to get a copy of the object that calls it. In this case, it's going to be the player itself, which we can also reference with the global variable player. Okay, first thing I'm going to do is pull out the x velocity, and you'll see why this is important in a minute. So I'm taking the player object and calling getLinearVelocity x on it and assigning it to the x velocity local variable. And I'm doing the same thing for the y velocity. Now, x velocity, if you have a positive x velocity, it's moving towards the right. If you have a negative x velocity, it's moving towards the left. That's very important because we can structure our animation around it. And the very first thing we're going to do is set up a flip function for the sprites. Now we're going to take a look at our x velocity first, because we're only moving left and right, and so the x velocity is really all we need to look at if we're talking about having a player face right and then flipping the sprite around to have them face left instead. So if the x velocity is greater than 0, in other words, he's moving to the right, okay, then we're going to set our flip. Set flip takes two parameters, x and y. So we're going to say we're going to flip it on the x plane and or on the y plane. So on the x plane, we're not going to flip it at all. It's going to be falsely flipped. On the y plane, it's also not going to be flipped. So when it's moving towards the right, we're not going to flip it, because right now it's always moving to the right. So when it's moving to the right, we don't want to flip it at all. Our other case is going to be if x velocity is less than 0. If that's the case, we're moving left. And if we're moving left, that means we need to flip our sprite along the x-axis. The first parameter for set flip is x, so we're going to set flip to true. And then we're not going to flip the y at all. And that's that. Let's go ahead and save it and see if this works up to this point. And there we go. We face left when we're running left. We face right when we're going right. Alright, we already have the basics of the player moving left and right. Let's get the up and down movement. Okay, so if our y velocity is greater than 0, or you get the or symbol by two pipe symbols, which is shift backslash, or my y velocity is less than 0, or going up, or player.airborne. I think that's sufficient. Player.airborne, sure. I want to encapsulate that in parentheses. It's getting kind of hairy looking. Okay, so now I have a case where I'm checking for any kind of upward or downward movement, or if the player happens to be set to airborne. First thing I'm going to look and see if he's going up. And the way we check that is we look at the y velocity and see if it's less than 0. If the y velocity is less than 0, then on our player we are going to play animation. And the animation we're going to play is player jump up. Oops, that fingered. Player jump up animation, and that comes from the Create tab on the actual player jumping up sprite. We've named him, back in the first tutorial, player jump up animation. Just making sure everyone's still awake. Okay, if his velocity is less than 0, we can also say that player airborne is true. And then we can get out of here. Because we don't care, we can use the return statement to get all the way out of the function, because at this point, if he's in a jump up state, we only have one animation for him, so there's nothing else he can do in this function, so we're just going to leave. And now we're falling, so same thing, except this time we're looking at y velocities to be greater than 0. Okay, so y velocity is greater than 0. Then we're going to play the animation. Player jump down animation. And if he's falling like that, then we have to say player airborne. I just caught that. That's a global variable player. Okay, so that's the upward and downward movement. So if we're going up, it's gonna play the jump animation and then bounce out. If it's going down, it's gonna do the same. And so now we can do the player running and standing animations. I like to check my work periodically, like to save periodically, like to get up and stretch periodically. And there he is falling. And he's still falling. Well, he's still falling because the jump's not working either. We've already set the variable airborne equals true, and we never have a case where it's false. Well, let's add in a not falling, or let's call this no lie movement. So if y velocity is exactly equal to 0, then we can say player.airborne is false. Okay, we can still move. Okay, he's jumping at least. Oh, that's right. When we set him down, or set him in the down animation, and when he hits, he's still in the down animation because we never told it to play any other animation. But we can jump twice, and he is looking up, playing the jump up animation when he's going up, and looking down when he plays the jump down animation. Pretty good. Now let's hop back into Xcode and finish off the player running and standing animations. Okay, first we can say, let's comment player standing. So we'll take our x velocity, and if that is exactly equal to 0, then we can play player stand animation. Okay, so if we ran it now, there he is, just standing in the middle of the screen. And he's sliding instead of walking left and right. But he's still jumping properly. So that means we need to finish off the running animation. Okay. So if he's not standing, the only other possibility is that he's going to be running. So we're going to use an else statement. So if it gets through the first condition here, and it's not true, then everything else must be true. Alright, so let's get that running animation going. Let's go ahead and throw a comment down. And the first thing we're going to do is we're going to see if we're already running the player run animation. So we do that by looking at the object this and running the method getAnimationName. Now that's going to come back as a string, so we're going to use string equals to test it against the name of the animation, which should be player run animation. Okay, so if we know we're in the player run animation, and we're continuing on the player run animation, we want to make sure that the animation continues to run smoothly, doesn't restart, doesn't stop in the middle of the animation or anything like that. So if the animation is running, we need to see if it's finished yet. And we do that by using get is animation finished, which will return a true or false. So if it is finished, which means it's just going to be sitting there in a non-playing state, then we're going to go ahead and play the animation again. And then we're going to, if we know we're running, then we're still running, then once we continue running, we can pop out of the function, because we're not going to need to affect the animation. We only need to affect the animation one way. If we're falling, then we need to play the fall animation and get a get out. If we're running, we play the run animation, then we get out. Speaking of falling, let me make sure that I have the return statement in there. Well, I've got one in for going up. Once I change the animation to a jumping, then I set my airborne variable to true, and then I return. When I'm falling, I need to do the exact same thing. Once I determine that I'm falling and I set the animation, I need to get out of the function. So I'm going to add the return line in there right now. If the animation is finished, then we restart it. If it's not finished, we're just going to let it continue on, so we don't need to do anything. However, if we're not on the player run animation, then we need to actually start the play animation for player run. And like all the other functions, once we're done setting our actual animation, we can return. Let's go ahead and save that. Okay, let's go ahead and give this a test now. We'll run it for the iPad, and we can see that we have a falling animation. When we get to the bottom, we stop. Let's try to jump again. Yeah, we're jumping up. And down. I can still move left and right. Okay, now let's try walking. I'm walking right. When I left the button up, I stop walking, but I'm facing the right way. If I hit the left button, then I am walking the other way. His jumping doesn't seem to be all that realistic. Let's go ahead and play around with some of the physics settings on the player. See if we can get him to jump a little bit more realistically. We'll select our player, go down to the Edit tab, and we're going to go back into physics, since that's the tab that controls all the external forces against us. Right now I don't have gravitic force on, so let's go ahead and turn that on and see what kind of a difference that makes for us. Wow, he's falling fast. In fact, he can't even jump. That might be a little bit too much force. Let's go ahead and cut that off, take off the gravitic force, and let's just make the downward force a little bit higher. Still not perfect, but it's a little bit better. Let's bump that thing all the way up to 2500 and see if we get any more love. Let's try another setting to see if we can get the physics to work a little bit more realistically. Let's go ahead and turn on gravitic scale, and let's turn down the downward y-force to 300. He seemed to fall pretty good, but he's not jumping very high. We can change that real easily by going back into Xcode and finding the player jump function. And right now we set his linear velocity y to -75. Let's make it -175. That way he gets a little bit more oomph. And he jumps up and lands, jumps up and lands. That's a lot better. Let's see if he can actually jump onto something. Not quite still. So let's go ahead and give him even more jumping power. Back in Xcode in the same spot. Let's make it 275 now. Back in the game builder, let's give it a run. Ah, that's much better. Now we can actually jump onto blocks.